Let us solve this differential equation by using the method of variable separation. So first we need to rewrite this differential equation. So we are going to multiply x plus y with dx minus dy. So that will give us x dx minus x dy plus y dx minus y dy. So that's equals to dx plus dy. And we write all the dx terms together. So we have x dx plus y dx minus dx, and take all the dy terms to the right hand side. So we have x dy plus y dy plus dy. So we'll take dx as the common factor. So we have x plus y minus 1 times dx, and that's equals to x plus y plus 1 times dy. So that means if we have dy over dx, so that will be simply equals to x plus y minus 1 divided by x plus y plus 1. So here we see that this is some function of x and y. So this means what we will do, we will assume that x plus y is equals to some variable v, such that when we differentiate both sides with respect to x, we have 1 plus dy over dx, which is equals to dv over dx, and then solving for dy over dx, we get dv over dx minus 1. So let's substitute this to our differential equation. We will get dv over dx minus 1 equals to v minus 1 divided by v plus 1. So we have dv over dx equals to 1 plus v minus 1 divided by v plus 1. Let's combine the two terms on the right hand side. So we have v plus 1, the v plus 1 plus v minus 1. So that will be 2v divided by v plus 1. So that means when we separate the differentials, we have dx is equals to v plus 1 over 2v whole multiplied to dv. So this is now in the separable form, and now we can integrate both sides. Before integrating, let's simplify the integral on the right hand side. So we have half integral dv plus half integral dv over v. So integration of dx will be simply x equals to half integration of dv will be v plus half times integration of dv over v. So that will be natural log of v plus the constant of integration c. And since we used v is equals to x plus y, so we'll have x equals to half of x plus y plus half natural log of x plus y plus the constant of integration c. And when you simplify it, our final answer should be x equals to y plus natural log of x plus y plus the constant of integration a. So this is the required solution to our given differential equation.